Hi guys, you're welcome back to my channel. Today we'll be looking at some question on the rate of diffusion. And as you all know, when you go to my video catalog, I have dropped a video on rates of diffusion. So as you all know that diffusion of gases is the movement of molecules from a region of higher concentration to a region of lower concentration. And if you have to look at this rate of a diffusion, don't forget we have the three states of matter. We have the liquid, the solid, and the gases. That is not where we are going. So when we look at the definition of or the law of diffusion from a previous video, which I dropped some formula extensively, today look at this question. A gas X diffuses twice as fast as a gas Y under the same conditions. If the relative molecular mass of X is 28, calculate the relative molecular mass of Y. It is very simple approach to this. So to all those students out there, please pay max attention. If I have the rate of diffusion of first gas divided by the rate of diffusion of second gas is equivalent to the square root of molar mass of second gas to the square root of molar mass of first gas, because from that question a gas X diffuses twice. When we talk about twice as a Jambite, this kind of question Jamb always play with it in different tier and they change the values. So how do you approach this kind of question? It is very simple. What you just need to know is that a gas X diffuses twice. That double. Either they can make use of twice or double. So that's 1, 2, because 1 times 2 give us 2. So guys, so we have this, our R1 is twice. Then our R2, so 1 times 2 is equivalent to what? 2. So now the molar mass of second gas, which is M2, and the molar mass of first gas, which is M1. According to the correction, a gas X diffuses twice as fast as gas Y under the same conditions. If the relative molecular mass of X is 28, calculate the relative molecular mass of Y. So those of you that with a past question, check Jamb 2002 number 20. I'm here without the option, but we are here to give you guys the solution, not here to just pick any answer without explaining. So let's go back to the class. So we have M2 and M1. A gas X diffuses twice. So yeah, we are given the relative molecular mass of X, which is what? 28. And here we have what? Unknown. So now we are all giving all the parameters now. So we need to just substitute all the values into the formula. So it is what? Very simple. So you can say we have 2 over 1 equal to the square root of M2 over the square root of what? 28. 28 is not a perfect square. I repeat, 28 is not a perfect square. So squaring both sides. So now we have this, we have this. So this will cancel this. And mind you, we said 2 raised to the power of 2 over 1 raised to the power of 2 is equal to M2 over what? 28. And we all know that 2 raised to the power of 2 is what? 4. 1 raised to the power of 2 is 1 equal to M2 over what? 28. So the next thing we're going to do is what? You cross multiply. So with that, you can say we have M2 multiplied by 1 is equal to 28 times 4. So class, M2 times 1 is what? M2. Don't forget the meaning of our M2, molecular mass, or we can make use of molar mass or relative molecular mass of second gas. So here is my calculator, and as I've dropped some videos since this week that Jamb will not provide you with scientific calculator. Rather, you provide it with what? This on-screen calculator. So you need to know how you are going to manage your time. So we have 28 multiplied by 4. So we have 112. So the relative molecular mass of the second gas is what? 112. So now I will solve a question relating to this before we move to the other question, because when we look at the law of rates or law of diffusion or effusion at a constant pressure and temperature. So now our answer here is what? 112 for our M2. So let's take a look at another question that is related to what you have on the board. This is Jamb 2014 related to the latest here. So let's take a look at it. I will have it on the board. So a gas X diffuses twice as fast as gas Y. You can see Jamb always play with question like this. If the relative molecular mass of X is 32, so we have 2014. Here we have is as number 4, but the value are different. So class, a gas X diffuses twice as fast as gas Y if the relative molecular mass of X, but here we are not given what? Under the same condition, so this is out of it. If the relative molecular mass of X is 32, calculate the relative molecular mass of Y. You can see that the correction is similar to the one we solved earlier, but here we don't have is under the same condition. So guys, look at what you have on the board. A gas X diffuses twice as fast as gas Y if the relative molecular mass of X is 32. Calculate the relative molecular mass of Y. This is Jamb 2014 number 4 compared to the one we solved from previous year. So guys, you can see we have the R1 and R2. Some students are funny enough that, please, as I've said earlier before we start the class, out, go back to my previous video. You will see a clear video on diffusion. So R1 is the same thing as the rate of diffusion of first gas, R2 rate of diffusion of second gas, M1 will come before what? M2, but here we are having this as a what? The numerator. Y is what? Denominator. So our M1 is molecular mass or relative molecular mass of first gas, while M2 is what? Relative molecular mass of second gas. So guys, look up. So a gas X diffuses twice as fast as gas Y, because you know I told you guys that the secret to this twice, or we can make use of double. When you said 1 times 2 will give you what? 2. But yeah, so we can say we have R1 as usual. In some cases, if you don't want to make use of R1, some tutor out there make use of the letter being stated in the question. So let's play with that also. We can say we have RX will give us 2. Our RY we have what? 1. So M1 and what? M2. Our M1 will be replaced with what? The relative molecular mass of X, which is what? 32. Why this will be replaced with what? Y, unknown. Are you with me, class? So now you can see it is clear now. So let's impute all the parameters now. So we change this one to what? X, Y, and what? X. So you can say we have our RX now is what? 2 over 1 equal to the square root of My, because we are actually for the relative molecular mass of Y. So let's make use of the letter. So we have what? M. Our Mx is given to be what? 32. The square root of what? 32. So squaring both sides and check the square. So here we have raised to the power of 2. Raised to the power of 2. So this 2 here has a power as a square to cancel this and this. So this will give us the square root of this and 1. We have My over 32. Are you with me now? So when you cross multiply, before you cross multiply, you look for the square root of this. So 2 raised to the power of 2 will give us what? 4. Power to the power of 2 will give us what? 1. So it is clear now. You can say we have My over 32. So when you cross multiply, we'll be having what? My multiplied by 1 equal to 32 times 4. So we can say my equal to, it's very simple if you are not meant to use a calculator, if you are familiar with your multiplication table. So we can say 4 times 2 is what? 8. 4 times 3 is what? 12. So we have what? My is 128. As simple as that. Are you with me in our class? So it's very well, very simple. So let's take a look at another question. And this kind of question deals with volume, time, and as well as our vapor density. So class, let's take a look at another question from previous year. So we have played with 2, and we're going to look extensively to a question which many students might find difficult to solve. So this question is also from previous year. So we have if 30 cm³ of oxygen diffuses through a porous partition in 7 seconds, how long will diffuse through the same pots? Why I'm using pots, because I can make use of some, you can come across some question whereby they make use of partition and pots. So I want to make use of the 2 here. So if of oxygen and chlorine are 16 and 36 respectively, so this is a Jamb correction to 1978. You can see that the question is an old question, but it's making sense because we are going to make use of some formula which I'm sure some of you have come across it before, but you don't know how to apply it. So the formula goes thus. So we have volume V1, we have our time, and V2 we have our T1 to give out the vapor density of second gas. It's called this vapor density of what? First gas. What you have on the board, if 30 cm³, we all know that any value you have either in cm³ or dm³ in chemistry goes for volume, and the one we have for seconds, we go for what? Time. A question like this under the Graham's law of diffusion, if you have watched my previous video on electrolysis, I convert from hour to seconds, but when you come to Graham's law, you provided your time in seconds already, so you don't have to stress yourself converting back from seconds to hours. No. So look at this now. Our V1 here, we have our V1 to be 30 cm³ of oxygen. Let's take note of that. Our T1, sorry, before we move to T, we have V2 is given to be 60 cm³ of chlorine. Then our T1 is given to be what? 7 seconds. Our T2, we don't know it, because if the vapor densities, as I've said earlier, that these are vapor densities, so our D1 vapor density of oxygen are 16, so we have this. Our D2, we have what? 36. So now you can see when it comes to this, when you get to your examination, all go with a pencil and your examination slip, you can make it of the back to solve, and go in with your eraser, because all these you have to get at all the parameters before you can solve any question under it. So guys, so we have our V1 to be what class? 30 cm cube multiplied by T2. Our V2 is 60 cm cube multiplied by 7 seconds equal, what is the vapor density of D2? Yeah, this is stated clearly. So we have 86 over what? 16. These two are perfect square. I repeat, 36 and 16 are what? Perfect square. So guys, let's continue. You can see that I have what? 30 cm cube. Or before we can proceed, you can see, 30 cm cube here will give us what? 1. Here we have what? 2. So we can see we have T2 over 2 multiplied by 7 what? Seconds. So the square root of 86, we all know 6. The square root of this will give us what? 4. So now we are going to cross multiply. So our 4 T2 equal 2 times 7 seconds give us what? 14 seconds multiplied by 6. So let's see, 14 seconds multiplied by 6 will give us 84 seconds. And here we have what? 42. So divide both sides by what? 4. So this cancel this. So our T2 is 21 seconds. You can see, as simple as that. So guys, let's take the last question. And before we move to the last question, please, when you are approaching a question like this, you don't have to rush. As I told you guys earlier, you can see, write out all the parameters there according to what you have on the board. Chemistry is not hard when you come across a good tutor. So now you can see it there. So let's take the last question. And so this question is not a calculation question, rather it is more of a theoretical question, and let's see how we can prove it out for you. This is a question under 2008. So, and to those of you who have issues with any of your chemistry topics, do well to drop your question in any of my videos in the comment box, and we will treat it. So we have this: diffusion is slowest in solid particles. Than in particles of liquid. And gases, because more kinetic energy than the particles of liquid and gases. solid particles So C, solid particle have less restriction in their movements than liquid and gas particles. Why the last one states the particles in solids are far apart and the cohesive forces between them are negligible. This one is Jamb 2008, number 6. So guys, look at what you have on the board. Is very simple, but how do we state or how do we define our answer? Diffusion is slowest in solid particles than in particles of liquid and gases because solid particles have more kinetic energy than the particles of liquid and gases. Okay, solid particles have less kinetic energy than the particles of liquid and gases. C, solid particles have less restriction in their movements than liquid and gas particles. The particles in solid are far apart and the cohesive force between them are negligible. You know, when we look at the three states of matter, the solid particles, they have strong force of attraction. You cannot easily move a solid particles because they have a definite shape and a definite volume. But why for liquid, they have a definite volume, no definite shape. So why the gases does not have either of the two, does not have a shape or does not have a what? A volume. So when we look at this now, for every solid particles under diffusion, they are very slow because you cannot easily move them or you push them. Just the way you can take your gas from one point to another or your liquid from one point to another. So let's see, solid particles have more kinetic energy than particles of liquid and gas. No, solid particles have less kinetic energy than the particles of liquid and gas. In our answer is B. You know, I may mention that liquid and gas are not, they can easily be moved, but our solid particles cannot be easily be moved. With that, it makes them to have a less kinetic energy. So let's take a look and see. Solid particles have less restriction. Yes, they have less restriction in their movement than no. So our answer is what? Solid particles have less kinetic energy than the particles of the gases, because when we talk about the diffusion, it's based on what? Kinetic energy. So guys, don't forget to subscribe to our channel. If you have any question you want to drop, you can drop that in our comment box, and stay tuned and put on your notification for more of our solution on Jamb.